Hello, this is Dr. D, and let's talk about the history of the development of the periodic table. This is John Newlands. He was a British chemist who lived from 1837 to 1898. In 1865, he proposed his law of octaves. Think back to the musical world and 8 notes on the scale. And he noticed that when you ordered the elements by their known atomic weights, they went in series of 8. And so he proposed his law of octaves. And the numbers that he assigned to these were just sequentially numbered by him. And so there were a lot of holes in this, and it didn't make a lot of sense from a chemical standpoint in many ways. And there was the music of the spheres. The music was very integrated into thought processes about science and whatnot at that day and time. So that's why he honed in on his law of octaves. That was 1865. Then in 1869, Dmitry Mendeleev, a Russian chemist, along with Lothar Meyer, a German chemist, independent of each other, proposed what has become our periodic table. By looking at the properties of elements, they saw that they periodically changed and periodically were very similar. And so he took the known elements at that time, 66 of them, and grouped them together. He came up with his periodic table that's shown here. Now, what was really neat about Mendeleev and why he wound up getting the credit for our modern periodic table is that he predicted the existence of some elements that weren't known at that time, that there were holes in his periodic table. And so he said there should be an element heavier than aluminum that would be right below aluminum on the periodic table that would have very similar properties. And so he called this undiscovered element Eka aluminum, where Eka is a Sanskrit prefix. That prefix means first, and that Eka aluminum would then be the first element under aluminum in that same group. And lo and behold, before too many years passed, gallium was discovered. And so because he was able to predict the existence of elements, Mendeleev is the one who got credit for our periodic table. But I want you to let you know about a College of Charleston professor, Lewis Reeve Gibbs. Besides being a chemist, he was an astronomer, geologist, mathematician, studied meteorology. He was a naturalist, studying plants and animals. Was a physicist, and also had a medical degree. And he was a professor here for a long time. And he was a member of the Elliott Society of South Carolina, which was a scientific society of his day. So he was born in 1810 here in Charleston and went to the University, what's now the University of South Carolina. It was called South Carolina College in those days. And after graduating there, he was an acting professor of math. And he published a catalog of phytogamous plants of Columbia, South Carolina's vicinity. That's a fancy word that means flowering plants. He went to the Medical College of South Carolina, which is now MUSC, where he received his MD degree. And after that, he traveled to France. And there he met some famous chemists such as Gay-Lussac, Dumas, Dulong, and he studied at Sorbonne and the Jardin des Plantes. So he's really quite the Renaissance man. Knew lots about lots of different sciences. He came back to Charleston. He was elected professor of mathematics and natural philosophy. That's what they called science back in those days here at CFC. He made observations of an astronomical kind, discovered some comets, talked about the transit of Mercury in a publication in 1845. Got married in 1848 to Anna Barnwell, and he's the one who constructed the Charleston Observatory here at the college, and had 8 children, and he studied all sorts of critters. You can see a page out of the Elliott Society about a crustacean that he studied in depth. And remember what was going on during this time. There was what Charlestonians were oftentimes referred to as the Great Unpleasantness. From 1860 to 1861 became what's known as the War Between the States. And after the War Between the States was something that was called Reconstruction that took place here in the South. And so he didn't know what was going on in Europe about what Meyer and Mendeleev had come up with in terms of a periodic table. Communications weren't great in the world those days, certainly not instantaneous like they are today. And being in South Carolina during the War Between the States and Reconstruction, communications were very poor. So he worked on what he called the Synoptic Table, which he wound up presenting at a meeting of the Elliott Society in Charleston. He presented it in 1875. He published it in 1886, along with some observations made from the earthquake that year. He published that in 1887. So he was very scientifically minded. But his Synoptic Table elements, he went about a little bit differently than Mendeleev and Meyer, who set the properties and arranged them in order of increasing atomic mass. Mendeleev did that in terms of increasing mass and then their properties. And you can see the charges, or what he would have called the valences, on the different elements that he had. And so that's Gibbs' Synoptic Table elements. Had the War Between the States not come along, and had Reconstruction not come along, he may have been 10, 15 years ahead of where he wound up actually publishing his work. And instead of having a periodic table of elements, we might today have a synoptic table of elements. And element 101, Mendeleevium, might not be that. It might be element GB now, Gibbsium. He wound up retiring in 1892 after his eyesight failed after 54 years here at the College of Charleston. He died in 1894 here in Charleston. So that was Lewis Reeve Gibbs. A little footnote to sort of close things off here about our history of the periodic table. Henry Moseley was an English physicist. In 1913, he discovered the correlation between the number of protons, which we now call the atomic number, and the frequency of X-rays that were generated. And so, up to now, the numbers that were given the elements were just sort of semi-arbitrary, just in sequential order, based on the masses that they had. And now Moseley was able to really show that those numbers meant something, that those atomic numbers were the number of protons. So that's a little discussion about the history of the periodic table.